Hi, good evening, everyone. So we will now start our chapter 8 for this semester, which is the last chapters we'll study. And we will not waiting too long as the the following slides will review something we have learned, and then we will get into some new things. So I will begin this lecture now. So let's recall our what is OOP which referring to the object-oriented programming, and it involves programming using objects. So what is an object? An object represents an entity in the real world that can be distinctly identified. Actually, you can regard anything as an object because anything in the world, it can have some attributes, it can have some behaviors as long as you can name it or maybe you can thinking about it, right? So for example, for a student, it has the student ID, right? A student can have the behavior of reading books, taking exams, and also a desk is an object because we can have the desks. For example, the color is its attributes, right? And the materials, whether it is metal or wood, it is an attribute, right? A desk can be like some, let me thinking of some behaviors. For example, okay, it has a drawers, right? We can take out the drawers and get it in. And for a desk, we can like upright it and make it downside, right? Okay, and let's see, a circle, for example, for another example, a circle can be an object which we have some attributes like the radius, right? The color of this circle, and what behaviors can a circle have, right? For example, if this circle is big enough, like we can using a Boolean expression to distinguish whether this is circle is qualified for a specific design or not, right? We can give it a specific behavior. And also a button, like the color of the button, and for the behaviors, we can turn off and turn on. Those are the objects. And even alone can be viewed as objects also. So an object has a unique identity, a state, and behaviors. The state of an object consists of a set of data fields, which is also known as properties. We say the properties are all those attributes with their current values. And the behavior of an object is defined by a set of methods. You can set these behaviors by yourself. And let's solve this one. So this is a class template. For example, we have the class name, which is circle, and the data field, we say that is the attributes, right? For example, this is the radius, right? And we can have some method. Oh, here is mentioned a method is get the area. So we using this class template, we can create a lot of class instances. For example, for a circle object one, right, we set its radius as 10. The second one, we set the radius is 25. For the circle, the third circle, we set the radius is 125, right? So an object can have a state and behavior, and the state defines the object, and the behavior defines what the object does. And the classes are constructed that defines objects of the same type. For example, this for the circle, the upper side, the circle, it is a class template, right? We say it is a class. A Java class uses variables to define data fields and methods to define the behaviors. We have done a lot of labs related to the fields and the methods. And if you're still struggling with understanding it, you can go through each lab, the recording. And additionally, a class provides a special type of method known as constructors. the constructors which are invoked to construct objects from the class. And we also say that the constructors is using to initialize an object, right? Because in the constructors, we always pass some values to the constructors. Let's take a look of class template there. For the circle class, we say that there is some data field, also known as attributes. Here we have the radius of this circle. So here we declare a variable, which is double type, right? And the variable name is radius. And we initialize the radius as 1.0. As here we are, since we, so can I using my pen? Wait a minute. Here it is the double, so we are using the fractions. And we declare the constructors, which is using to initialize the classes. Here it is the default constructor. And as you can see, we can have nothing there, right? And then we can still overload another constructor there. Here we pass the new radius to this constructor. And then we assign the new radius to the radius itself here. So in this case, we can initialize a circle by passing a number as a radius. And then we should have some method at the behavior. Here we say that get area, which returns the radius multiplied by radius multiplied by pi there, right? It is the area for this specific circle. So let's see the UML class diagrams there. Here for this circle, usually the first compartment is the name of the class name. It is a circle. And in the second compartment, we put the data field there. Here, since we have only one data field, which is the radius, right? We only put radius here, and the following by the column is the data type, which is double. And in the third compartment, we have our method. The first two is always the constructors. And for the constructors, we have our human designed method there, like get area, get parameters, and set radius. And you can also have some others method designed by yourself. And once you have the class template defined there, you can using the template to initiate a specific circle instances. For example, here, the circle one, we set the radius as 1. The second one is 25. The third one is 125 there. Those are 3 concrete instances. So let's try to run this example. I don't know what happened with the network. Try CS dot Armstrong. Or for example, Liang. I should go back to, sorry, I should go back to CUNY. And here, this one is fine, but the other one is not good. So let me go to chapter 8. Where is test simple circle? Okay, we don't have to test the simple. Oh, here. Okay, let's run this method. Let me check whether you can see it or not. Okay, you can see it. So animation, start animation. So let's go through this method together. So this is the line starts from executing from the main method. So the next line, we create an object and assign the reference to circle 1. And the simple circle is something we already defined in our program. And then let's take a look over this simple circle. Okay, this is the simple circle, but why the test and simple circle is the same? Okay, this is the simple circle. And this is a test simple circle. Okay, they are the same. So here the statement create an object and assign its reference to circle 1. And for the new something, right? New simple circle, we just saw there is such Java class there. So we invoke the simple circles constructors. This is since we don't pass any parameters there, we will invoke the default constructors there. So next our code is going through the line 31. Here we defined the circle class with 2 constructors there. As you can see here, this is the class for the simple circle. And here is the default constructor for this class. And in the default constructor, we set the radius as 1. Let's go to next line. And go to next line. Okay, once we have invoked the default constructor, and now we have a concrete instance there. That is the circle 1, right? And it is also indicated in here. Radius 1. Now we have our object 1. So let's implement the next line. And here we are going to display the circle radius and the area for the circle 1. Once we have done with the line 6, we will move to our line 10. Here we using the second constructor of the simple circle to create an object and assign its reference to circle 2. And when we are creating the circle 2, we pass 25 to the simple circle because we are using the parameters to initialize an object of the simple circle. Right here, it says that this statement will create an object by invoking simple circles constructors. Then we will move to here. In the downside, for the class simple circle, we will execute the line 36. Here, right, we can see that a constructor circle with a specific radius. We pass 25 to the new radius. That means now the new radius represents for the 25 there. So when we execute the next, the 25 is assigned to the radius. And then let's go to next. And then the object is assigned to the reference variable circle2. As you can see in the right-hand side, the circle1 is referenced to, pointing to the address of the circle1 simple circle objects there. And the circle2 is pointing to the circle2 column simple circle with the radius of it is 25 there. That means we have now two circles in our memory. And after that, we're using a statement to display the radius and the area for the circle2. And then we are using the same thing. We're using the same way to create our circle3. And here we also using the second constructor to initialize our circle there. And this statement also creates an object by invoking the simple circles constructors. Here we also still moving to the line 36 that we passed the 125 to the new radius. And now let's move on to the next line, which is 37, that the new radius value 125 is assigned to the radius for the circle3. Okay, as you can see here, now the circle3 is pointing to the third concrete circle instances there. And with the radius is setting to 125 there. So after that, there is a print statement that telling the users the radius and the area. And now here is how can we modify the circle radius. We can using the statement like we're using the object's name, which is the circle2, and also it can be changed to circle1 and circle3 there. And followed by this in object name, we can use a dot indicating a reference to a specific field. Here we say the radius. That means a dot is pointing to the circle2's radius. Now we are assigning 100 to the circle2's radius. So let's see, initially the circle2's radius, we said it is as 25, right? Now we change it to 100. So after that, we implement the next line of code. So in this case, the statement display the updated circle radius and the area for the circle2 there. And that is for this snip of code. So let's go back to our slide there. So another example is defining class of TV. So here we have a lot of fields and method there, right? Okay, let's go through it. For a TV, we can have a data field like the channel. For example, the current channel is 1 to 120 of this TV, right? It's a specific kind of attributes. And the second one is the volume level for the TV. For example, for the current volume level is 1 to 7. That if you cannot hear clearly, you can increase the volume level so you can making the speaker speaks clearly. And then we can have a third data field that is on. And we set it as a Boolean variable because it only indicates whether the TV is on and off. since there is only two states, right? We can using the Boolean, because for Boolean variables, we only have two concrete values can be assigned. One is true, the other one is false. So it is naturally can indicating whether a TV is on and off. And then we can design some behaviors for a TV. And here, comparing to the previous UML class, we now, in this slide, we have a plus sign that indicating the modifier. For example, here, the plus means it is a public method there. And if you see something as a minus symbol, that means it is a private or protected behaviors there. I guess you will learn a lot about the differences between the public and the private in your advanced Java classes there. So let's see what behaviors the TV class is containing. The first one is the constructor method, right? We use the constructors to initialize a default TV object. We can pass the channel or volume level and the on state. We can pass the default value of the three data fields, data variables within our constructors. And the second and the third one is turn off and the turn on method, which means that you can turn on this TV or turn off this TV. The third one is set channels. That means you can set a new channels for this TV. And the fourth one is set volume. It is the same thing that you can set a new volume for the TV. And also, except for setting something, you can also change something, right? Like change the channel up and down and change the volume up and down. And that's for it. So let's take a look over the TV class. Let me see whether we can try it online. I pretty like this website. You can find it in the table of content, other resources, supplemental examples from introduction to Java programming, because those examples are pretty straightforward for you to understand the program. And now I will show you how to read it. Okay, it doesn't have animation there, so we will go through the other one. Okay. Do we have, okay, it doesn't have line by line execution. So we cannot demo it. But it's okay. Okay, let me explain it. Here in the text, the TV show the line codes. Okay, in the line 3, right, we create a TV. And in the TV, let's go back to this. Let's go back to the TV class. Where is the TV? Okay, here is the TV. In the TV class, it has 3 attributes there, right? As we are just talking about the UML class here. Let's go back there, right? We have 3 attributes. So in our code, we can design the 3 attributes accordingly. We're using the data type int for channel and the volume level. And we set the default channel is 1 and the volume number is 1. And we set the TV on and off by false. That means the TV is off by default. And then we, using the empty constructors, we put our empty construct there since we already set the default value in the data fields there. If we don't initialize those data fields, we can set the data fields like 1/4 inside the default constructor there. And after that, we are doing something related to the method. For example, for the turn on method here, inside this method, we assigning the true to the on, which means that, okay, we are now turn on the TV. And in the other side, we assign the false for the attributes on. That means, okay, we are turning off this TV. And also for the setting channels and the setting volumes there, he used if statement to restrict the channels. It's between the channel 1 to channel 120. And also for the set volume, it using it restricts the volume level from 1 and 7. Also, please be sure that, as you can see, it has another restrictions that the on is always in the first place of the Boolean expression. It is because only when the TV is on, you can change channel and the volume, right? If the TV is off, you cannot do anything with him. So also for the channel up and the channel down, volume up and volume down, this code using the self-increment to help increase the channel and volumes level. So I think for this example, it's pretty straightforward, right? So let's take a look over the test TV class. Here in the line 3, it creates a TV, and then in the line 4, it using the TV1 dot turn on to call the turn on behavior, which means now we turn on the TV1. And then we using the set channel method to let the TV display the channel 30 there. After that, we using the set volume method to change the volume level from the default 1 to 3. Once we have done with our TV1, we then new our another TV object there, and we give a name of TV2 there. And we also do almost the same thing here. The first thing we have to do is turn off our TV2, right? So that's why we call the TV2 dot turn on. So in this case, we can make the TV on rather than off. And after that, we call the channel up. That means we are going to increment our default channels by 1 from 1 to 2 here. And we call the channel up again. That means now we are going to change our channel from 2 to 3. And for the line 12, we call the method of volume up. That means we are going to increase the TV2's volume from 1 up 1 level. Then that means now the volume level currently is 2. So once we have done with that, we're using the print statement to display the current state of the TV1 and the TV2. And that is the code for the TV class. Okay, let's get back to our class there, our slide there. Okay, let's take a look over the constructors. Recall what is a constructor. We have mentioned a lot of times a constructor is a special kind of method, right? And that are invoked to construct objects. What is construct objects? That means we are going to using the constructors to initialize our objects. For example, we have a template. We have to using the template to create a concrete thing, right? We know there is a circle, and we know we are going to create a circle, but what is the radius of this circle, right? As long as you invoke the constructor, and then you will know what is the radius. because it is set by ourselves. And a constructors with no parameters is referred to as a no arguments constructors. Also, we say it is a default constructor. And the constructors must have the same name as the class itself. And we can see here in the circle class, all the constructors, no matter it is default one or our human designed one, the class name are all circle, right? The only differences is the parameters list and the content for this method. And for the constructors, we do not expect they should have a return type. Usually they are not, and not even void. And the constructors are invoked using the new parameters when an object is created. As we can see in our test examples, we always using the keyword new a class, right? New something with some specific values on the numbers inside the new class names, right? Immediately after the class name and between the parentheses. And constructors play the role of initializing objects. So you should always remember that a constructor is going to initialize an object. For example, here, right? We have, suppose we have a circle class. How can we creating an object using the constructors? For example, if we are calling the circle pass without any parameters, so it will invoke the default circle class and set the parameters as by default. If we are passing the 5 in the new class name, so that means here the radius is set it as 5.0. Okay, let's recall what is a default constructor. As we can see in the previous slides, right? We say that a class may be defined without constructors, but in this case, no argument constructors with an empty body is implicit defined in the class. What does it mean? That if you forgot to write constructors in your class, and the result is, the consequence is the compiler will create no argument constructors with an empty body for you. So you don't need to worry about that there is no constructors because there is always no argument construct there. However, sometimes it will make the program go wrong. So usually you should be carefully dealing with the constructors because you have to be careful to set the default values for the classes. So this constructor is called a default constructor, which is provided automatically only if no constructors are explicitly defined in the class. And let's see what is declaring object reference variables. Okay, to reference an object, assign the object to a reference variables. We can using such syntax, right? A class name, the object reference variables. For example, circle, my circle. Actually, I know it's kind of a little bit abstract for you to understand what is a reference. So we say a reference is always a pointer in C++. That means, okay, we have a name right here, right? My circle. And we create, usually we create our objects in the heap. Suppose we have a circle 1 there, right? We create a circle, a concrete circle with radius is equal to 5. We create something, and this is created by using the new method, new circle 5, right? Once we met such a kind of code, we will know that, okay, we are going to create a circle class in the heap, only in the heap. And then we assign the new circle to a specific class name, right? A variable name. For example, here, my circle. And we can write it like new circle 5, okay? And this is a complete line of code there. A reference means that we are connecting this data variable name to the variables created in the heap. That means from now on, my circle is pointing to or reference to this address. And this address stores the circle object with radius 5. So we say this is a reference. It's pointing to somewhere, we say. And as you can see, since we are creating a circle, okay, it seems that the yellow is not working well. While using the highlighter. As you can see, we are creating a circle, right? That means this object is in a type and the data type is circle. So that's why when we are declaring such a line of code, we declare the reference variables, we should keep the data type same, right? And this is circle. A circle, a reference pointing to a data type is circle, and then we should declare it first using the circle there. So these are always the same. And maybe in your advanced Java class, these two can be different because we will have our parent class and the son of class or even grandson of class. So usually in the left-hand side is the parent, in the right-hand side is the son. But that is not what we are going to learn in this semester. Okay, that is what we are just talking about with references. A class name usually going to the first, right, here. And after that is the object reference variables. Object reference is pointing to somewhere. And we are using the new something always to create an object. And then as we just simply mentioned how to referencing the object's data. For example, we are using the object's variable's name, right? We say that is object reference variable's name. And we're using a dot symbol there to present it as a reference. And then we call it the data's field, right? Here we say that is a radius. And we are always using the same thing like the dot to invoke the object's method. It's the same thing. The method is displayed there. Get area. You can pass arguments or not pass it. Both are correct. And let's trace this code. Here we declare my circle. That means, okay, now we are going to have a data object. The object's name is my circle, right? And the type is circle. The type is circle, but currently we have no values there. We are only declaring something. And then we create a circle in our heap. Okay, each time I should stress that it's in a heap. We create our data objects. And for this data objects, our field is setting the radius as 5, because here we are calling the constructors by arguments. And then we use the assignment symbol there to reference a value. Actually, we say reference is always indicating an address. That means the reference value usually is the address name. For example, suppose here the reference name is OXEE216, right? That means the starting point of the circle object in the memory is OXEE216. So in this case, the compiler will know where to fetch these data objects. And this is the address. Okay, and then we are using the default constructor to initialize your circle. Okay, now since we have my circle, and then we are going to create and declare and create your circle. Here, when we are declaring something, as long as we didn't assign something there, okay, currently there is no value. But once we have our new and we are using the assignment, that means, okay, we are connecting the variable's name, which is your circle. We are connecting it to the data objects created in our heap. So we assign the object reference to your circle. However, in the third line, we change the radius in your circle to 100.0. And let's see how we are invoking the data fields. We are firstly write the object's name there, right? Your circle. And then we're using the dot to call the radius field. This is the field. Data field, let's say. And we assign the 100 to it. That means we are changing the data field. And then there's something you should be careful. Okay, let's recall that you use the math.method name arguments. For example, math.power 3, 2.5. That means we are going to taking 3, 2.5, power 3 to 2.5 there. It is to invoke a method in the math class. But can you invoke getArea using simple circle.getArea? The answer is no, because all the methods used before this chapter are static methods, which are defined using the static keywords. Okay, we have stressed this thing. For those static methods, we do not need to create an object. However, for the getAreas, those are non-static methods. You must firstly invoke an object and then use it. That means you should always firstly new something, new object, reference variable, and then you can use it like this. So more explanations will be given in this section on static variables, constants, and the methods. And we will also talking about it in our next lectures to do our lab on chapter 8. As we say that the data fields can be of reference types. For example, for the following student class, which contains a data field named of the string type. Okay, actually there is, for the student class, we have 4 data fields. The first one is name, the second one is age, the third one is science major or not. Okay, here we should be careful, it is Boolean. And also we have the fourth data field, that is the gender, we are using a char to indicate it. If a data field is a reference type, doesn't reference any object, and then the data field holds a specific literal value, that is null. That means currently we are only declaring it, right? We are not, we didn't assign any value for it. So if you want to know the default value for the name, age, major, gender, okay, for the age, it is an integer, right? So default value, the age default value is 0. For the Boolean, is we say it is always false, right? And as we just mentioned that here, for a reference type, we say usually it's reference to string and the classes we created. So for those things, the default values are always null there. And if we are declaring a character, the default value is \u with 4 zeros there. Okay, that is the null value. And this is what we have mentioned, that default value for a data field. We say we are assigning this one for the character type. Okay, he said that, however, Java assigns no default value to a local variable inside a method. Well, let's see. This example here, okay, we have integer x, we have string y, and if we want to print out the x and y's default value, and then the compiler will give us an error indicating that the variable not initialized. Okay, that is only happened with Java. So maybe in C++ or C or even Python, it may output something, but in Java, never. Okay, let's see the differences between variables of primitive data types and object data types. For primitive data types, as we say that it is integer, right? Or maybe double and something else. Those are primitive types. And we say when we are initializing it, we are using a specific value to initialize it. For example, I is equal to 1 is 1. And when we are dealing with the reference types, for example, here it is object type, right? Suppose we are declaring a circle C. And actually, this supposed to be circle C is equal to new circle, okay, 1 there, right? So here, this thing we say is the reference. And the reference is pointing to the new circle class, which is stored in our heap. Suppose we say the beginning address, right? Is OXEE221. And here the reference means that we will store the OXEE221 there. So that means the compiler will know where to find the object C. And then it will fetch this thing and then go to this address. Now the circle 1 is stored in the memory address. Okay, we have some specific ways to copy the primitive data types and the object data types, but things is a little bit different. For example, suppose we have the primitive data type I and j. Before I is 1, j is 2. And what if we are assigning the we are assigning j to I. For example, currently I is 1, right? And then we have our second line, j is 2. And then we change the i's value. We are using j to assign I. That means, okay, here we assigning 2 to I, making the I changed from 1 to 2 there, because current j is 2. But what if we are copying reference type, data type, object types there? Suppose before the first one, C1, we say the reference, right? C1 is pointing to OXEE221, right? And here we say the circle 2, C1, C2 is pointing to OXEE229. That means here the address is OXEE221. The address for this one is OXEE229. Okay, we want to, now the code for this example is like this. For example, C1 is new circle 5, right? C2 is new circle 9. And then we want to assign C2 to C1. So here we have our C1 is pointing to an address of OXEE221, and C2 we have the address of OXEE229 there in the memory. So if we are executing this line, that means, okay, we are changing the address stored in the C2. No, I mean, we are changing the address stored in the C1. Initially, it stored the value of OXEE221, right? The address. But now we are giving this content to here. That means we are copying the address OXEE229 here. So when compiler executes this line, it will know that C1 is now pointing to this address, OXEE229. So as you can see here, now we have two variables pointing to the same address, which is the circle 9, right? Here. So we say the object type assignment here is assigning the address, or we say the reference, rather than the concrete value. For the primitive type assignment, we only assign the value there. Like suppose it is 2 and then we assign 2. If it is 5, we assign 5. It is 9, we assign 9. However, this is only happened with primitive type. And you may have another question, for example. Here we say, what if once we change the C1 to C2, right? What if, suppose I say I update C2 dot, right, radius to 10. So if I want to print, sorry. Is C1 dot radius. What is the numbers should print out? Okay, let's analyze. So currently C1 and C2 are pointing to the same address, right? So since they are pointing to the same object, and the circle 2 currently its radius is 9. But we are using the C2 dot radius equal to 10 to assign the new value to it. So now it has been updated to 10. However, we using C1 to invoke the radius for the object there, right? This is C1. Okay, C1 is here. So what should it print out? As currently C1 stores the C2's address, which is EE229, right? EE229. That means C1 is pointing to the circle C2 with the radius updated already. So in this line, it will print out 10 there. Because here we already updated to 10. So that means if we are using the reference data types, when we are assigning the object types, right, we only change the reference, but we cannot control the actual value stored in that memory. That means they are, for the C1 and the C2, they pointing to the same address. They are pointing to the same objects there. Okay, no problem. But once I changed this object, that means no matter which references, C1 or C2, I am using, the value stored, or we say referenced to, will be changed accordingly. No matter which C1 or C2 we use, both these two variables will getting the same updated value there, because now these two are pointing to the same address. Okay, it's a little bit difficult to understand, but just try to understand it. This is the difference for the reference and the value. If you take the C++ or C course, you may have a better understanding of it. But if you are not, it's fine. I totally understand. And we are going to talking something about garbage collection. Actually, you are not required to master it, but I'd like to introduce something to you. At least you should know such a term, which is garbage collection. So as we show in the previous figure, after the assignment statement C1 and the C2, we assign C2 to the C1. That means we have given the C2's address to the C1, right? And now C1 points to the same object referenced by C2. Okay, this is a pretty important sentence there. C1 points to the same object referenced by C2. And the objects previously referenced by C1 is no longer referenced. Okay. That means the previous reference for the C1 is not valid there. And this object is known as garbage. Is known as garbage. That means, okay, this one is garbage. And the garbage is automatically collected by JVM. And we say that you can take it as, okay, we throw the garbage into the garbage bin, and the JVM will destroy the memory, or we say clean that piece of memory, so we can reuse the garbage place for other purpose. If you know that an object is no longer needed, you can explicitly assign a null to a reference variable for the object. And the JVM will automatically collect the space if the object is not referenced by any variables. Okay, it's just a tip. Okay, let's say, let's take a look of the data, the date class. Okay, the date class is default class within the Java utils package. And Java provides a system-independent encapsulation of date and time in this date class. You can use the date class to create an instance for the current date and time, and use its toString method to return the date and time as a string. Okay, let's take a look over it. And the first line is a default constructor there. and it constructs a data object for the current time. Okay, please remember it's a current time. The second one construct a data object for a given time in the milliseconds elapsed since January 1 and 1970. We're using the time zone of GMT. And if you are in New York, right, we are in GMT +4, if I'm not making it wrong. And there is a toString method there to help us to return a string representation of the date and time. And we also have the getTime method. It will return the number of milliseconds since January 1970 GMT. And also we have a method to set time. We set a new elapsed time in the object. And let's see the examples of using the date class. Here, since if you are importing the packages, for example, import java.util.date there. And you are not required to write this. What you have to do is only write a date there and new java.util.date. Or even you don't need to have this. Just new date. And then when you are printing out the date toString, it will return you a string looks like, okay, some March 9th, and this is the specific time there. And last lectures, we are trying to using the math.random to obtain a random double value, right? At last lectures, we are using the random double to create some questions. For example, like 1 multiplied by 7 is what? If you can remember that. And it is a useful random number generator, this one, provided by this package. And here is some common method provided. For example, the first one, it constructs a random object with the current time as its seed. Current time as its seed. What is a seed? A seed is something that if you set it specifically here, for example, we say the random 1.11111, it's a seed. That means each time you are using the same thing, you will generate a same set of random numbers. That is the seed. And if we are using the random method and call the next int, it will return a random int value. If we are using the long or double or float or even Boolean, it will return as the random accordingly data types value there, right? As we can see from the slide. And let's see the example. Okay, if two random objects have the same seed, they will generate identical sequence of numbers. Okay, this is what we have talking about. And for example, the following codes create two random objects with the same seed 3. Here it sets the seed as 3. So each time we run this piece of code, it will always generate the same thing. For example, 7346660, something like that. And the random 1 and the random 2 always keep the same each time. That is the feature for the seed. And we still have some other Java APIs pretty easy to use. For example, in the JavaFX geometry packages there, we can call the APIs to create 2D graphs there for representing a point in a 2-dimensional plane. For example, we can call it using the point 2D. The first parameters represents for the x-axis and the y-axis for the second parameters. And we can also call the distances for the x, y. It will return out the distance between it. And also we have some getter method like getX. We will return the x-axis and the y-axis coordinate. All right, that is a coordinate rather than axis. All right. Then we will discuss something about the instance variables and the method. Okay, we say that an instance variables is belonging to a specific instance. That means if we are creating different instance, we will have different instance variables there. And the instance method are invoked by an instance of the class. That means only when you have a concrete instance object of a class, you can use the instance method. If you only have the class template, you are not allowed to call the instance method. However, if that is a static method, okay, you no longer need to create an instance. You can call the static method by its class name directly. We will talking something more about it in the next lab. And instance variables and method are specified by omitting the static keyword. Because instance, you will always remember that the static keyword is always related to classes. And the instance thing is only related to objects. We say a concrete thing. Since we say that the static variables, right? The static is related to class, okay? And we say a class is a template, right? So that means those static variables are shared by all the instances of the class. That's why if we are calling the instance variables or instance method, what we have to do is only using the class name and using a dot, and followed by it is the static variable thing or static method name. And the static methods are not tied to a specific object because it is tied to a class. And the static constants are the final variables shared by all the instances of the class. It is also because it is related to class. So to declare a static variables, constants, and method, we'll have to use the static modifiers, for example, here. Let's take a look. Okay, here we don't have. Okay, we have in the UML notation, okay, we say we use the underlying static variable to indicate the static variables or method. That means, okay, this is instance variable. And this is static variable, right? And for this one, since we have an underline there, that means, okay, this is a static method. Now, this one is just an instance method. Okay, when we are initializing them, for example, if we are creating a circle, now the instance is always related to the object itself, right? We have the 1 there. We set the radius as 1. And for the second one, we can set it as 2, right? However, since the static variable here is always shared by all the class, right? We have mentioned in our previous slide. Let me use the highlighter. So the number of objects is shared by the circle 1 and the circle 2. As you can see, these two numbers are the same. They are pointing to the same memory address, and they have the same value, that is 2. So that is the difference between the instance-leveled variables and the static, we say the class-leveled variables. Since the static things always shared by the whole class, so they share the same values within the concrete instance there. So here we are going to take a look over two pieces of method. Here we are going to demonstrate the role of instance and the class variables and their use. And this examples as a class variable number of objects to track the number of circle objects created. Okay. I should change switch to the heap. We should switch to here. Show code with line lines. Okay, let's take a look over the circles with static members. Here we have two, as we just saw in the UML class there, right? We have two data fields. The one is radius, which is bind to the instance. We say the circle 1, we have the radius of 1. The second circle, we have the radius of 9, right? However, we have a second data field that is static int, number of objects, right? And both of the circle 1 and the circle 2, they share the same number, that the number of objects is equal to 2, right? This is the two data fields. And then we have our some constructors. For example, here for the default constructors without parameters there. Okay, I have to remind you that for our constructors, we always have the same name. The method name, the constructor method's name is the same as the class name. Don't forget. So within the default constructors, we use the 1.0 as the default value to the radius. After that, after we initialize specific instances, we increase the number of objects there, which is the static one here. It seems like it's a counter to count how many objects we have already created, right? And the second one is human designed constructors. We include our parameters, which is the double new radius here in the parameters list. So once we call it, we pass the new radius. Here it is our human designed numbers to the radius to initialize the radius. And once we have done that, we also increase the static instance variable, that is the static variable number of objects by 1. So that means, okay, we create one more instances there. Okay, the remaining 2 is pretty straightforward. The remaining, the first one more method, get number of objects. Since here is get the number of objects, that means we are going to return the number of objects, right? It's a static value. So the method modifier, oh no, not modifier, the data type is static int, right? Because number of objects is static. And then we have our get area method there. So we just return the radius multiplied by radius multiplied by mass.pipe. And then we just return such a thing. It's supposed to be a double value. That's pretty straightforward with this class with static members. So let's take a look over the test method there. Okay, this one? No, this is creating the 2 points. Okay, it doesn't give us an example there. So let me check whether we don't have example there, but it's okay. We will do a similar program in our next lecture. So let's get back to the our slide. And then the next thing we are going to talking about the visible modifiers and the accessor mutator method there. If you can remember that, we have talking something in our UML class, right? We say that, okay, the first compartment is circle, right? And the second compartment is some data fields like radius. And the third compartment is method, right? We say circle is a constructor or get area, right? And initially we say both of them we are using a plus symbol. That means a public class, right? Now it's time to explain what is a public class and what is a private class too. This is a two thing. A public class means that the class, for this class, the data or this method, as long as it has the keyword of public, that means the according class data or method is visible to any class in any packages. Okay, any class in any packages. However, if we are using a private keyword there, that means the data or method can be only accessed only by the declaring class. You can say that within the same class. That means, for example, if you are using a minus there, that means if you are creating a circle test class, right? And then you want to call a method, right? You want to call the get area to calculate. Since it is a private one, so in this class, you cannot perform such a function. However, within the circle, within this data class, if there is a function that, for example, toString, right? In the toString, you are going to get area. Okay, it's totally fine. You can use the get area method because it is within the same class. But if it is outside the class here, you can no longer call this method or any data. If it is, for example, if the radius here is minus, no, you can no longer access to such a value. And we say the getter and the set method are used to read and modify the private properties. Okay, this is pretty important. And this is the reason that why previously we are writing something like getter name, setter name, getter value, and setter value. Okay, let's take a look over these 3 examples. In the first example here, we have our public X, Y, and Z. And we have the method M1, M2, and the private method M3. Okay, let me take out. Okay, okay, let's see. The private is for Z and M3 there. Okay, and here is the package P1, and in the same package, okay, the same package P1, we have another class that is C2. Okay, here we have a method there. We can new a C1. Okay, this is no problem. And then we can access OX. Okay, we can access OY there, but we cannot access Z because it is private. And here in this method, we can invoke M1 and we can invoke M2. However, we cannot invoke M3 because M3 is privated. And let's see, what if we are since they are in package 1 right now, we are in package 3. Okay, we are also testing the method. We now have our class C3. Now we create a new class, which is C1, right? Okay, no problem. It can access O1. No problem, because it is public, right? It's okay. However, it cannot access OY because there is no public before the int y there. So it means it is a protected type. And also for M2, since there is no public there, right? We cannot invoke O.M2 and O.M3 because it is protected value. Only for those methods with explicit public, we can use it across different packages and across different method. So I will highlight this. So for example, here, right, we have OX, no problem. For the public, void one, M1, okay, M1 we call there, right? M1 we call there. However, for those things, for the protected thing, okay, we cannot access this. We cannot access it through different packages, but we can still visit within the same packages. For this one, we can still visit through, okay, sorry. We can access it through the same class. Okay, this is OY. But we cannot access because here is P2. We are in different packages. And the same thing is for the method. So we say the private modifier restrict access to within a class. The default modifier restricts access to within a package. And the public modifier enables unrestricted access. So this is within a class, within a package. And the unrestricted access. Okay, let's take a look over the simplified version, right, of the P1, P2, P3, package 1. We say the default modifier on a class restrict access to within package, and the public modifier enables unrestricted access. Here, we only say what is default modifier. Default modifier is you may cannot find it. we don't have anything before the public, right? The class 1, it is where is my pen? Oh, it's changed to yellow. It is a protected class, but here we have a explicit public there, right? We have a public there. However, it is in package 2. So that means we can this for since they are in the same packages, so it can access the C1 there. How things they are in different packages, it cannot access C1. Since it is public here, it can access C2. It's fine. That's the difference. And please note that an object cannot access its private members as shown in this example there. For example, here we say in the left-hand side, we have a public class C there, right? And here we knew a C, and since it is a private Boolean, we can print this method directly. And even if this is private, we can still using it because it is within same class. However, when we are changing to another class, right? For example, here we knew a C. Since the X is private, and this convert method are private. Okay, we are no longer allowed to access those data and the method only because they are in different classes. That's the reason. So why data fields should be private? The first thing is we should protect data. For example, suppose you have data which is student. You have data that is student there, right? And you may create a student name, the age, right? And if you are making it public, that means maybe I have a vehicle class, right? Vehicle. We can create a student, right? And then we can modify the S1 student name as anything. We say, okay, it's a cat. Nobody wants to be a cat, right? So that means, okay, it is manipulate this student record. However, if we set it to be private, so this action is no longer valid. That's why we say that it is to protect the data and to make the code easy to maintain. Since we are not mess up with other code, so the code is naturally easy to be maintained, right? Okay, we still have several slides, but it's okay. We will talking about it in our next lectures. We still have 20 slides, but it's okay. So our course is ending here. If you have any questions, you can leave. You can come to me. Otherwise, you can leave now. Thank you for attending today's course. Okay, good night, Aiden. Good night, everyone.
Matt, I have a question.
And remember, if you don't complete the exam 2, be sure to submit your exam 2 by 25th. If you have any emergencies and want me to extend the deadline, you can always come to me. Although I will deduct some portions of the grades from your answer, but you still have some, right? This course is B plus guaranteed, but I
Miss, I
hope
was going,
everybody can working hard on it. At
Miss,
least trying to pretend you are a good student. That is the attitude thing.
Miss, I have a
Okay, thank
question
you. Good night.
for the homework.